Okay, here is our reading of Lesson 3, the theory of plate tectonics. And first, let's start with our essential questions. What is the theory of plate tectonics? What are the three types of plate boundaries? And why do tectonic plates move? So what's causing them? So we're going to learn about the when two plates come together, of course, it's called a boundary. And so we're going to learn about the three different types of boundaries and what causes these plates to move around in the first place. So that's what this lesson is about. Let's look at the vocabulary. Plate tectonics, lithosphere, divergent plate boundary, transform plate boundary, convergent plate boundary. So let's talk about the words there for just a moment. So diverge, to diverge means to move apart. The word diverge is used in Robert Frost's poem about the path in the woods, and it says the road the road diverged, so it came apart. One went one way and one went the other. Okay, so anyway, that word diverge means to move apart. Transform. Okay, we're going to learn about a transform. Think about transform as to change somehow, so keep that in mind as we read about transform plate boundaries. Converge. Okay, to converge means to come together, and so we're going to see that convergent plate boundaries have to do with coming together. Then subduction, convection, and we've talked about convection before. Remember, we talked about three different ways to move heat. We talked about conduction, radiation, and convection. Convection has to do with the movement of particles and the movement of heat due to the movement of particles, and it has to do with, if you remember, has to do with density of the particles. So as the density changes, because the warmer particles move farther away from each other, so as the density changes, it changes where the particles are. So the particles move. So if, for example, when air gets warm, it moves up. And so we're going to see that the convection inside of the earth is what's the cause of this movement of plates. All right, then we're going to find out about something called a ridge push and a slab pull. Okay, well, let's look at the picture here on this page for a moment. So this picture is a picture of the Aleutian Islands off the southern coast of Alaska. So it says this photograph shows a chain of active volcanoes. These volcanoes make up the Aleutian Islands of Alaska. Just south of these volcanic islands is a 6-kilometer deep ocean trench. Why did these volcanic mountains form in a line, and can you predict where volcanoes are? Are they related to plate tectonics? And we are going to see that there's a certain type of plate boundary where there will be more volcanoes. And so we're going to look at that, and maybe we can come back to that and talk about what kind of plate boundary that would be. Okay, let's look on page 323, the plate tectonics theory. When you blow into a balloon, the balloon expands and its surface area also increases. Similarly, if oceanic crust continues to form at mid-ocean ridges and is never destroyed, Earth's surface area should increase. However, this is not the case. The older crust must be destroyed somewhere. But where? By the late 1960s, a more complete theory called plate tectonics was proposed. The theory of plate tectonics states that Earth's surface is made of rigid slabs of rock or plates that move with respect to each other. This new theory suggested that Earth's surface is divided into large plates of rigid rock. Each plate moves over Earth's hot and semi-plastic mantle. All right, our key concept check says, what is plate tectonics? Plate tectonics is a theory that Earth's surface is made of rigid slabs of rocks or plates that move with respect to each other. Geologists use the word tectonic to describe the forces that shape Earth's surface and the rock structures that form as a result. Plate tectonics provides an explanation for the occurrence of earthquakes and volcanic eruptions. When plates separate on the seafloor, earthquakes result and a mid-ocean ridge forms. When plates come together, one plate can dive under the other, causing earthquakes and creating a chain of volcanoes. When plates slide past each other, earthquakes can result. On the top of page 324, you see the Earth's tectonic plates. So if you check the key out, if the arrows are moving away from each other, that's an example of a divergent boundary. If they're moving towards each other, that's a convergent boundary. And just in general, the plate boundaries could be also a transform boundary where they're sliding past each other. Okay, so we can see there's a lot of different plates. Let's find us. Where are we? Well, we are on the North American plate, and so this is the edge of California. Okay, and you can see that this is a convergent plate boundary right here. These are sliding, actually. That's why California has so many earthquakes, because these two plates are sliding. It's a transform boundary, so they're sliding next to each other. Okay, well, let's take a look at our text. Okay, tectonic plates. You read on the previous page that the theory of plate tectonics states that Earth's surface is divided into rigid plates that move relative to one another. These plates are floating on top of a hot and semi-plastic mantle. The map in Figure 11 illustrates Earth's major plates and the boundaries that define them. The Pacific plate is the largest plate. The Juan de Fuca plate is one of the smallest plates. It is between the North American and Pacific plates. Notice the boundaries that run through the oceans. Many of these boundaries mark the positions of the mid-ocean ridges. And you can take a look at that. Let's go back up and look at that briefly. So where these plates are next to each other in the ocean, this is where you would find the mid-ocean ridges, all through here, the Atlantic mid-ocean ridge. So Earth's outermost layers are cold and rigid compared to the layers within Earth's interior. The cold and rigid outermost rock layer is called the lithosphere. It is made up of the crust and the uppermost mantle. The lithosphere is thin below mid-ocean ridges and thick below continents. Earth's tectonic plates are large pieces of lithosphere. These lithospheric plates fit together like the pieces of a giant jigsaw puzzle. The layer of Earth below the lithosphere is called the asthenosphere. This layer is so hot that although it is solid, it behaves like plastic material. This enables Earth's plates to move because the hotter plastic mantle material beneath them can flow. The interactions between lithosphere and asthenosphere help to explain plate tectonics. Our reading check says, what are Earth's outermost layers called? Well, the Earth's outermost layers, which include the crust and the uppermost mantle, make up the lithosphere. Okay, on page 325, plate boundaries. Place two books side by side and imagine each book represents a tectonic plate. A plate boundary exists where the books meet. How many different ways can you move the books with respect to each other? You can pull the books apart, you can push the books together, and you can slide the books past one another. Earth's tectonic plates move in much the same way. Divergent plate boundaries. Mid-ocean ridges are located along divergent plate boundaries. A divergent plate boundary forms where two plates separate. When the seafloor spreads at a mid-ocean ridge, lava erupts, cools, and forms new oceanic crust. Divergent plate boundaries can also exist in the middle of a continent. They pull continents apart and form rift valleys. The East African Rift is an example of a continental rift. Transform plate boundaries. The famous San Andreas Fault in California is an example of a transform plate boundary. A transform plate boundary forms where two plates slide past each other. As they move past each other, the plates can get stuck and stop moving. Stress builds up where the plates are stuck, and eventually the stress is too great and the rocks break, suddenly moving apart. This results in a rapid release of energy as earthquakes. Convergent plate boundaries. Convergent plate boundaries form where two plates collide. The denser plate sinks below the more buoyant plate in a process called subduction. The area where a denser plate descends into the earth along a convergent plate boundary is called a subduction zone. When two oceanic plates collide, the older and denser oceanic plate will subduct beneath the younger oceanic plate. This creates a deep ocean trench and a line of volcanoes called an island arc. This process can also occur when an oceanic plate and a continental plate collide. The denser oceanic plate subducts under the edge of the continent. This creates a deep ocean trench. A line of volcanoes forms above the subducting plate on the edge of the continent. Over time, an oceanic plate can be completely subducted, dragging an attached continent behind it. When two continents collide, neither plate is subducted, and mountains, such as the Himalayas in southern Asia, form from uplifted rock. Table 1 on the next page summarizes the interactions of Earth's tectonic plates. Key concept check. What are the three types of plate boundaries? The three types of plate boundaries are divergent plate boundaries, transform plate boundaries, and convergent plate boundaries. All right, so looking at table 1 on page 326, here we have the divergent plate boundary. So when two plates separate, they come apart. And so it can cause a rift valley or a mid-ocean ridge. And here's an example of what that looks like. The process occurs where the seafloor spreads, forming new crust and hydrothermal vents. And so that's what we're looking at here, the hydrothermal vents. This process can also occur in the middle of continents and is referred to as continental rifting. So a lot of times we think of divergent plate boundaries as that oceanic crust, and we did a lab on that where the seafloor was spreading. That's an example of a divergent plate boundary, but we also have them within the continents. And so if continental crust is coming apart, it's called a continental rift. All right, let's look at transform plate boundaries. Okay, so transform plate boundaries. Two plates slide horizontally past one another along a transform plate boundary. Earthquakes are common along this type of plate boundary, and the San Andreas Fault, shown to the right, so I have a picture over here of the San Andreas Fault, is part of the transform plate boundary that extends along the coast of California. Okay, so they rub against each other and often parts break up. And so in the lab that we're doing with graham crackers, you'll see the graham crackers will actually kind of, little pieces of them will come off. Okay, it causes, and the pressure that you feel when you push the graham crackers together is modeling the pressure that is along this plate and causing earthquakes to happen. Okay, our convergent plate boundary, there are two different types that we're going to talk about. So it can be an ocean to continent, and that's what this one is. And so when an oceanic and a continental plate collide, remember that the oceanic is more dense, and so it will subduct. So they form a convergent plate boundary, and that denser oceanic plate will subduct. It will go under the continental crust. So a volcanic mountain, such as Mount Rainier in the Cascade Mountains, forms along the edge of a continent. This process can also occur where two oceanic plates collide and the denser plate is subducted. And we saw that.
Oh, there's another bunny outside.
Okay, we saw that when we looked at the Aleutian Islands picture at the beginning of this lesson, because the Aleutian Islands is a line of volcanoes that are forming where the Pacific plate is being subducted under the North American plate. And so it forms a line of volcanoes, and there's a trench on one side that it talked about. That trench forms the boundary between the two tectonic plates. Okay, now let's look at the convergent plate boundary continent to continent. So convergent plate boundaries can also occur where two continental plates collide. Because both plates are equally dense, neither plate will subduct. Both plates uplift and deform. And this creates huge mountains like the Himalayas shown to the right. So when two plates that have about the same density come together, one's not going to go underneath the other one. Instead, they push each other up. It's kind of like nobody wins. And so they push each other up and forms these mountains. So you can see mountains over here like the Himalayas. Okay, so we've learned about plate tectonics theory and the different types of plate boundaries. We're going to next talk about the evidence behind all of this and then the cause of it, what's causing it. So when Wegener proposed the continental drift hypothesis, the technology used to measure how fast the continents move today wasn't yet available. Recall that continents move apart or come together at speeds of a few centimeters per year. This is about the length of a small paperclip. Today, scientists can measure how fast continents move. A network of satellites orbiting Earth monitors plate motion. By keeping track of the distance between these satellites and Earth, it is possible to locate and determine how fast a tectonic plate moves. This network of satellites is called Global Positioning System. The theory of plate tectonics also provides an explanation for why earthquakes and volcanoes occur in certain places. Because plates are rigid, tectonic activity occurs where plates meet. When plates separate, collide, or slide past each other along a plate boundary, stress builds. A rapid release of energy can result in earthquakes. Volcanoes form where plates separate along a mid-ocean ridge or a continental rift, or collide along a subduction zone. Mountains can form where two continents collide. Figure 12 illustrates the relationship between plate boundaries and the occurrence of earthquakes and volcanoes. Refer back to the lesson opener photo. Find these islands on the map. Are they located near a plate boundary? And so the Aleutian Islands, we don't have to look back at the picture to know, we're looking at the Aleutian Islands. So this is Alaska up here, and that would be the Aleutian Islands, remember? So that is where the Pacific, meets the North American plate. That's where we have the Aleutian Islands. So you can see all of the red triangles are active volcanoes, and then the blue is earthquake epicenters. So there are a lot of earthquakes and active volcanoes at the edges of all of these plates. And this is something called the Ring of Fire. Okay, so they call this the Ring of Fire because of all the volcanoes that you can see around here. All right, plate motion on page 328. The main objection to Wegener's continental drift hypothesis was that he could not explain why or how continents move. Scientists now understand that continents move because the asthenosphere moves underneath the lithosphere. Convection currents. You are probably already familiar with the process of convection, which is the circulation of material caused by differences in temperature and density. For example, the upstairs floors of homes and buildings are often warmer. This is because hot air rises while dense, cold air sinks. Look at figure 13 to see convection in action. So at the bottom, the water is heated and it moves to the top as it becomes less dense. The colder water at the top moves towards the bottom, so it causes a convection current. Reading check. What causes convection? So convection is simply caused by the differences in density and temperature. All right, looking at, let's see, let me move this down a little bit. So plate tectonic activity is related to convection in the mantle, as shown in figure 14. Radioactive elements such as uranium, thorium, and potassium heat Earth's interior. When materials such as solid rock are heated, they expand and become less dense. Hot mantle material rises upward and comes in contact with Earth's crust. Thermal energy is transferred from hot mantle material to the colder surface above. As the mantle cools, it becomes denser, and then sinks, forming a convection current. These currents in the asthenosphere act like a conveyor belt, moving the lithosphere above. Key concept check. Why do tectonic plates move? So tectonic plates move because the mantle moves horizontally under Earth's plates due to convection currents. Earth's plates carried along by the moving mantle below them. Okay, and moving on to the next. Okay, so you can see a picture of that here. So the convection currents that are being formed by the heating of the mantle and then the rising of the less dense material, and then as it cools, it sinks. And so that movement pushes up against these plates and it moves them like a conveyor belt. Forces causing plate motion. How can something as massive as the Pacific Plate move? Well, figure 14 shows the processes that determine how convection affects the movement of tectonic plates. Basal drag. Convection currents in the mantle produce a force that causes motion, called basal drag. Notice in figure 14 how convection currents in the asthenosphere circulate and drag the lithosphere, similar to the way a conveyor belt moves items along at a supermarket checkout. Let's see, ridge push. Recall that mid-ocean ridges have greater elevation than the surrounding seafloor. Because mid-ocean ridges are higher, gravity pulls the surrounding rocks down and away from the ridge. Rising mantle material at mid-ocean ridges creates the potential for plates to move away from the ridge with a force called ridge push. Ridge push moves lithosphere in opposite directions away from the mid-ocean ridge. And slab pull. As you read earlier in the lesson, when tectonic plates collide, the denser plate will sink into the mantle along a subduction zone. This plate is called a slab. Because the slab is old and cold, it is denser than the surrounding mantle and will sink. As a slab sinks, it pulls on the rest of the plate with a force called slab pull. Slab pull is thought to be a more significant force than ridge push in moving tectonic plates. A theory in progress on page 330. Plate tectonics has become the unifying theory of geology. It explains the connection between continental drift and the formation and destruction of crust along plate boundaries. It also helps to explain the occurrence of earthquakes, volcanoes, and mountains. The investigation that Wagner began nearly a century ago is still being revised. Several unanswered questions remain. Why is Earth the only known planet in the solar system that currently has plate tectonic activity? Different hypotheses have been proposed to explain this. Scientists have found evidence of plate tectonics in Mars's past. Second question, why do some earthquakes and volcanoes occur far away from plate boundaries? Perhaps it is because the plates are not perfectly rigid. Different thicknesses and weaknesses exist within the plates. Also, the mantle is much more active than scientists originally understood. What forces dominate plate motion? Currently accepted models suggest that convection currents occur in the mantle. However, there is no way to measure or observe them. So what will scientists investigate next? Figure 15 shows an image produced by a new technique called anisotropy, I'm not really sure how to say that creates a 3D image of seismic wave velocities in a subduction zone. This developing technology might help scientists better understand the processes that occur within the mantle and along plate boundaries. Reading check. Why does the theory of plate tectonics continue to change? The theory of plate tectonics is modified as new data are obtained, often through new technologies that help scientists better understand the dynamics of plates and plate boundaries. Okay, on page 331, let's do the lesson review. Number 1 asks, the theory that proposes that Earth's surface is broken into moving rigid plates is called plate tectonics. Number 2, Compare and contrast the geological activity that occurs along the three types of plate boundaries. Well, earthquakes are associated with all types of convergent plate boundaries. Plates separate along divergent plate boundaries. Earthquakes and volcanic eruptions are common along divergent plate boundaries. Plates collide along convergent plate boundaries. Volcanoes occur where plates of different densities collide along a subduction zone. Mountains form where two plates of the same density collide. And plates slide past each other in opposite directions along a transform plate boundary. Earthquakes occur along transform plate boundaries. Number 3 asks, explain why mantle convection occurs. Mantle convection occurs due to the transfer of thermal energy in the mantle. Radioactive elements in the core heat the mantle. Hot mantle material rises to the base of the crust and cools, sinking back down into the mantle. And this process creates circular currents in the mantle called convection currents. Number 4, tectonic plates move because of A, convection currents. Number 5, name the type of boundary between the Eurasian plate and the North American plate. All right, let's look between Eurasian and North American. It looks like the arrows are going away from each other. So between those two, it would be a divergent plate boundary. And then it says also between the Nazca plate and South American plate. So let's find those. Here's the Nazca plate. Here's the South American plate. Here the arrows are going towards each other. So it would be a convergent plate boundary. Number 6, determine cause and effect. Copy and fill in the graphic organizer below to list the cause and effect of convection currents. Okay, so the rising and the falling of the mantle is what causes the convection currents. So we've got convection currents, and what do they do? Well, the convection currents have some effects like moving the plates. And we talked about the different ways that happens, the different types of plate movement. All of those different types of plate movement together will cause things like earthquakes, volcanoes, and mountains to be built. Okay, number 7 says, explain why earthquakes occur at greater depths along convergent plate boundaries. Well, earthquakes occur at greater depths along convergent plate boundaries because slabs of rigid rock sink deep into the mantle along a subduction zone. As this cold, old, and rigid rock sinks, stress accumulates with increasing depth. When stress is released along a subduction zone, an earthquake occurs. Let's look at the math skills on number 8. So 2 plates in the South Pacific separate at an average rate of 15 centimeters per year. How far will they have separated after 5,000 years? We can look at this as a unit conversion problem. So 5,000 years is what was given. And if they separate at a rate of 15 centimeters per year for 1 year, the years will cancel each other out, and you'll multiply 5,000 times 15 to get 75,000 centimeters, which is equal to 75 meters, and that will happen in 5,000 years. And that concludes our review.